Electronics engineering versus electrical engineering. Electronics engineering is the study of behavior of electrical charge carriers in semiconductors. There are two charge carriers in semiconductors, namely electron and hole. Electron is a negative charge carrier and hole is a positive charge carrier. All the electronic circuits functioning does involve the movement of both these charge carriers. Electronic circuits are designed to process, modulate, transmit and demodulate the information. The raw signal is converted to an electrical signal like voltage and currents. Electrical engineering is the study of behavior of electrical charge carriers in conductors. There is only one charge carrier and that is electron. All the electrical circuit functioning does involve the movement of electrons only. Also, electronics deal with MV, mA and MW. Whereas, electrical deal with kV, and MW. Electrical engineering is the major field of study that encompasses electronics engineering. Electrical engineering could be thought of to not only include electronics but power generation and distribution, motors, electromechanical devices, computer engineering, certain computer programming disciplines, communication, optics, MEMS, magnetics, transformers, bioelectronics, radio and lighting. Electronics is often thought of as encompassing analog and digital and RF design and optoelectronic and components, as well as computer engineering and computer architecture. By association and application of electronics critical to the technologies, it is also well involved in some way with the most of the items on the electrical engineering list above. The main difference between electrical and electronic circuits is that electrical circuits have no decision-making, processing, capability, whilst electronic circuits do. An electric circuit simply powers machines with electricity. However, an electronic circuit can interpret a signal or an instruction, and perform a task to suit the circumstance. Most electronic components are very small, and require small direct current, DC, voltages. A single microprocessor, which will fit on the end of your finger, may contain hundreds or thousands of tiny components, some of which are only a few atoms wide. Electrical components tend to be larger, and use alternating current, AC, voltages. Whilst most electronic components operate on 312 volts DC, electrical appliances require 230 volts AC. The link between electronic and electrical circuits is typically provided by relays or transistors. These are essentially switches but, rather than being pushed manually like a light switch, are operated by a small current from an electric circuit. Therefore, a small circuit, often with many tiny components, can be used to operate much larger electrical equipment. This makes using household and industrial products safer, and means they are smaller and more energy efficient. Electric uses only passive components, such as resistors, capacitors and inductors. They are called passive because they do not act upon the current, voltage passing through. Electronic is when a component is active, or apply some transformation of the current. A filter made of resistors, capacitors and inductors is electric. The same filter, using at least a diode, a transistor and or an op-amp is active, and electronic. Usually, if there is a vacuum tube, a semiconductor or some sort of amplifier, we talk of electronics. Electric device means a device which works by using electric power or current, and its working principle or working area is shown whoever sees it. Whereas electronic device means it can work by consuming electric power or battery power, but we cannot see the working principle, that is, how it is working, and just we see the result. Electronic devices are pre-programmed and it consists of chips, which are small pieces, Encapsulation of programs. The distinction between electrical and electronic components/elements is twofold. The former, like electric wires/cables, resistors, etc., are passive, that is, they do not require a power supply for operation. Secondly, the output power of the signals applied to them can never exceed the input power, that is, there is no power amplification. Electronic components like valves, transistors, etc. are active components. They need their own power supply for operation and also, depending on the design, may or may not provide power amplification. Flow of current through conductor called electrical, like copper, aluminium, while flow of current through semiconductor called electronics, like silicon, germanium. In electrical, working voltage is very high voltages and low constant frequency. For example 60 HA, and voltage is 220 volts, 440 volts. While in electronics, working voltage is low but its frequency is very high. For example, mega HA, voltage is 6 volts, 10 volts, etc. The main difference between electrical and electronics is, in electrical we study current through conductor. Electronics we study current through semiconductors. Thank you.